All right, so getting down to the end of, or almost the end of some of the smaller parts, the next part I'm going to draw is the pin. And the pin right here is the thing that you pull on the fire extinguisher. When you pull this pin, this top handle, when you grab it, you can squeeze this together. And what it does is it opens a valve so that the ingredients, the stuff inside the fire extinguisher, rushes out of this hose. Um, with the with the drawing itself, I did a little sketch here. It's an eighth of an inch in thickness, so it's just a piece of round stock bent at an eighth of an inch. There's an overall distance. There's a distance you have to calculate, and there is a diameter for the pin itself. And there is a little trial and error on this, and so I will try to remember my trial and error. But the one thing going back here is that there's this one note, and it says loops 1 1/4. It says inches, but what I should have said was turns. Or circumferences or something from a quadrant. So you can see what I did was I marked A, and A is the intersection of the point where the pin is in a straight line, and then the second portion of that is where the loop on the spiraled portion ends. So if I look right here and I start my mouse, I say, okay, the pin is going straight through the handle, and that's all straight. And it gets to here where my cursor is, and that's what I called quadrant A. If I follow the loop around, it goes all the way around, and then it hits quadrant A, and that's one loop. And then it passes quadrant A, and if you look how far it goes down, if we called this like quadrant B, that would be a second loop. Or if we said, okay, this is starting at the 12 o'clock position, it goes down to 3, comes down to 6, goes up to 9, comes back to 12 o'clock, and then it keeps bending until it gets to 3 o'clock. Okay, so this involves some slicing, it involves some unioning, and some sweeping, and exploding, and then everything else. So if I look, I'm going to start myself off with a sort of something to kind of contain my parts. And so I know that the outside diameter of this is 1.150, okay? And I know that the overall distance is 2.650, okay? Not 26.50. Whoops. Line 2.650. Okay. So there's that. Maybe I should have made this a little bit bigger. And I know that I have right here, straight down from this, I have this end of it just coming down, and I'll just draw this into space. This is flush. This is where my diameter of 1.150 should exist, down here. So I'll go diameter of 1.150, and what I'm going to do is do 2 moves. One move is going to be, I'm trying to get it pushed down so it's straight away right there. It's intersecting. And then I'm going to do one other move, keeping polar on from this quadrant to here, and that's intersecting. Hey, Mr. Bank, can I get back with you? I'm doing a video right now. Cool. So there we go. I've got a circle and I've got a straight line, and now I'm all set up. So what I can do is draw a line. I know that my pin length goes to this quadrant on the circle, and that was the unknown distance. Okay, so what I would do is I would go to my pin. I would lock my construction layer, and then I would draw a line that just goes from here to right there. Okay, and this line, oops, I might have locked the wrong one. Nope. This line, so it's hard to get, I'm having trouble getting my pin line off of it, but let's see if I unlock my construction layer. Maybe I have to switch. Okay, so I can get this. I'll move this out of the way. And this line right here is my the length of the straight section of the pin. Right at the end of that, I can draw a circle with a diameter of 0.125. That's an eighth of an inch. The pin layer is really hard to see, so I'm going to do a little bit of a color change here. Pin. I might as well just make it. I'll make it blue. Okay. All right, that'll be better. So now I'm going to use a tool that I don't use it very often, but I'm going to go to a Southwest isometric, and I'm going to use under draw. You'll see the top left tool, so it's in the drop down. You can see I just clicked draw. You have the Helix tool. So Helix works just like a circle, but you have two diameters. So if I click Helix, I start the tool, it asks me for a center point. That center point sure doesn't look like the center of that circle. That looks more like it. So if I entered a one diameter, let's say I said the diameter had to be 0.7, just showing you how that works. And now I go to, and my Helix froze. Okay. The second diameter is the top diameter. So you have to enter the diameter twice. In this case, the Helix is the same on the top as it is on the bottom, but in what I just did, it's not at all. Okay. So all you have to do is enter. We know that the diameter is 1.15. So I'll go Helix, and I'll grab right here. Now, rather than having to enter that number again, you can just snap to the quadrant, and that will guarantee that the Helix is at the same exact size. Okay. Now you can see it's saying right here in the command window, what is the top radius or diameter? And this is where I click again, 1.150. So now you can see my Helix is completely all the way. It's right around the. It's following the same pattern all the way around. This is where I had to guess a little bit, and if I recall, I think I made this point. So it was 0.125, and you got to think that if I have a circle that's 0.125, nearly touching itself, so maybe this is the thing to do. Draw a circle with a diameter of 0.125. We have to figure out how far apart, what does the height of this helix have to be so that it creates enough space so that one circle can sweep on top of the other part. So I think what I did was I figured out through some trial and error that had to be 0.4. Helix one more time. Here we go. I seem to be Helix. Let's try this one more time. Helix. Starting from center, diameter 1.150. Top diameter 1.150. Height 0.4. Okay. And that hopefully is enough. So the thing you can do is copy all the work you did. And this is what I was saying is the trial and error portion. So copy the work you did, swing it over with polar lit up. There we go. And now turn off the construction layer. And what you want to have happen is you want this line that leads into the helix to go straight in. So what I'm going to do is rotate this from here around this hoop, and I went negative 90 degrees. And now I'm going to move this to that part. So you can see now my helix is in a straight line with the pin. Okay. I would join also, grab my circle, and so that it travels down the path. Morning, Alex. So that the circle travels down the path, what I would do is go ahead and join the straight line with the spiral or with the helix. Okay, so right here and here, those would be joined. Now you can see when I hover over it, it's one thing. And now I'm just going to go ahead and use my sweep tool. And one of two things is going to happen. It's going to say it's unable to sweep, and that would be because, so let's see what happens. Click that, right click enter, click this, and hopefully, oh, it did. It's swept. So that is perfect. 0.4 would be that height distance, okay? And that allows you to sweep this all the way around. If I had said like 0.3 or something, if that wasn't tall enough, what would be happening is this would be running back into itself. It would be self-intersecting along the pathway. If I made it 1, it would be real tall, and it would look more like a coil spring. Okay, so that is the first point, and I'm real happy with that. So the second thing, remember we said that this has to take 1 1/4 turns, which means if I follow the pin, it has to go around 1 time, get back to here, and then go around 1 more quarter time. So I'm going to come back and do that on video number 2, deal with the slicing and making that up as it needs to happen.